If you think being a front-end engineer is just about writing CSS and making things look pretty, you're missing the bigger picture. In reality, front-end engineering is about optimizing performance, managing build pipelines, ensuring smooth deployment, and scaling applications efficiently. Yet most people completely overlook these crucial aspects. In this video, I'll break down what a real front-end engineer does, covering build optimizations, CI/CD, deployment strategies, and performance tuning so you can level up your front-end game. Let's start with build optimization. First, you need to understand which parts of your code are contributing most to the build size. Bundle analyzers can help you with this. Add them to your project and check the build sizes and identify which code segments are increasing the bundle size. You can then use this data to take targeted optimization actions. Let's say there is a date formatting library which was adding 300 KB to the initial bundle. The solution would be dynamic imports. But here's the crucial part. You need to understand which components can be loaded later. I'll show you my decision making process for code splitting with an example. Let's say you are building a dashboard application with multiple widgets like charts, tables, and user analytics. When a user first loads the dashboard, they don't need everything immediately, only the core layout and essential data. So instead of bundling everything into a single massive JavaScript file, we can lazy load non-essential components. Step 1 would be identifying what can be deleted. Let's break this down. We have two segments, components that must load immediately and components that can be loaded later. In the first segment, we have navigation, sidebar, and dashboard skeleton. And in the second segment, we have heavy components like charts, data tables, and advanced filters. Step 2 would be to implement lazy loading. Instead of importing all the components upfront, we dynamically import the heavy ones using React's lazy and suspense. Now, based on the changes above, we can see the results. The initial bundle stays lightweight, loading only essential UI elements. The chart and table are fetched asynchronously, reducing the first load time. By doing this, the user experiences a faster and smoother page even on slow net. Now let's talk about error boundary implementation. Error boundaries are your safety net in React. They catch JavaScript errors anywhere in the component tree and displays a fallback UI instead of crashing your app. In this modern implementation using hooks, we are not just catching errors, we are handling them gracefully. When an error occurs, we show a user-friendly message, logs the error for debugging, and keep the rest of the application running. All of this has saved us countless times, especially with third-party integrations that might fail unpredictably. Custom 404 and error pages. Okay, so now let's enhance our 404 page with some powerful features. When a user hits a 404 page, we gather some valuable information using document.referrer and router.aspath. Document.referrer tells us where the user has come from. Was it Google or a broken internal link? This helps us fix navigation issues. For example, we discovered that a lot of our users were trying to hit old blog URLs. So we set up proper redirects. Router.aspath shows us what was the exact URL the user was trying to reach. In our application, we use this to suggest the closest matching valid page, track commonly requested missing pages, automatically create redirects for common typos. These small improvements significantly reduced our lost users. Now let's demystify CI/CD, continuous integration and continuous deployment. When I first started, I used to manually check my code, run tests and deploy. But this used to take a lot of time and was error prone. So here's what I changed. Imagine having a robot assistant that automatically checks your broken code for errors, run all the tests for you, ensures your application still builds correctly, checks for performance regressions, and if everything passes, deploys your code. That's CI/CD for you. The best part about CI/CD is it runs automatically. Just push your code and let the pipeline handle the rest. No more wondering if you forgot to run the test or check bundle size. Let's talk about security, especially content security policy or CSP. Think of CSP as a security guard for your website. Every time a resource tries to load, whether it's a script, an image, or a font, CSP checks if it's allowed or not. Here's a real scenario. Let's say one of your third party scripts was compromised and tried to inject malicious code into your website. But because you had CSP in place, the attack was blocked instantly. Your users were not affected and you got an immediate alert. So, CSP helps you to control which domains can load resources, prevent XSS attack by managing script execution, monitor and report security violations, protect your users' data. The most valuable part is CSP gives you detailed reports whenever something suspicious happens. These technical practices have helped me in becoming a more effective front-end engineer, and I hope that you got to learn a lot from this video and understood the importance of these topics to grow as an engineer. Let me know in the comments below which of these topics you weren't aware of at all and would want me to cover these topics in detail. I will surely make another video on the same. Thanks for watching. Keep coding, keep learning new things. Until next time, bye bye.